This is going to be a video that will cover the entire lesson for complex numbers. This is the first lesson. There are going to be 2 lessons for complex numbers. But this one will be the first one, and I'll go through the entire part of it. That way, if you were sick or you missed it, or maybe you just need a little bit more practice, then this might help a little bit. Okay, so today we're going to be learning what an imaginary number is. We are also going to learn how to add and subtract, multiply and divide, or multiply, not divide. We're going to do that next time. Multiply complex numbers. I like this lesson because you finally get to find out what the square root of -1 is. You've seen those sometimes whenever you're doing the quadratic formula, or maybe you've seen those sometimes when you're doing other math problems and you're not sure what to do with those. So we're going to learn a little bit about what those are and how to use them today. All right, an imaginary number it comes from the square root of -1. The square root of -1, we're going to call that I. That is not a variable. That is a very distinct designation that goes into just an imaginary number. I is equal to the square root of -1. Well, if I is equal to the square root of -1, then we find out a little bit more that I squared is going to be -1. Remember, when we square a square root, it kind of gets rid of it. So if you want to think of it that way, that the squared and the square root cancel each other out, that's a good way to think of it. All right, so we've got this, and again, I is not a variable. It's a symbol for a very specific number. Okay, so I've got this one. I've got the square root of -81. Traditionally, we couldn't do that. If we could break it apart, though, it might make a little bit more sense to us. If we break this apart, this is the same thing as the square root of 81 times the square root of -1. Well, the square root of the square root of 81 is 9. The square root of -1 is I. So this is really just 9i. Okay, we can break those apart. And this is what you're going to want to get in the habit of doing here. Let's try this one. I want you guys to try this one. Go ahead and just try it right now. You don't even have to pause the video. It should hopefully be a little bit easy enough. We know that 121 is a perfect square. Hopefully you can identify that that is 11 times 11. So the square root of 121 is just 11. And then we've got this negative. We can break those two apart. And that is square root of -1, which is I. Okay, I want you to try these two. For this one, I do want you to push pause. Try to obtain your answers. After you've obtained both answers, come back and push play. Check your answers here. The first one was pretty easy, 5i. The second one, you actually had to simplify a little bit. You found out that it was 10i square root of 2. Notice how this I is out in front. We don't want to have this I inside the radical because it's -1. Square root of -1 is I. So it needs to be out in front. So make sure that when you're writing those out in front. Okay, so let's go through this one now. We've got 8i times 3i. We kind of treat these similar to the way that we treat a variable. I know these are not variables, but we treat them very similarly as we go through these processes. Okay, so 8 times 3 gives me 24. Then I go I times I. Well, I times I is I squared. So now I've got 24i squared. But we know what I squared is. Remember, I squared is -1. So if we know I squared is -1, that's the same thing as 24 times -1. And 24 times -1 is -24. So that is our answer here. Okay, so now we're starting to learn how to multiply with these imaginary numbers. Let's try this one right now. And this one's an interesting one. 8 times 20, we got -8, square root of -8 times the square root of -20. What I would always suggest that you do is try to pull out this I, this square root of -1, first. Okay, so whenever I break these two apart, I've got right here. See where that came from? This is 4 times 2 is 8. This is my I here, square root of -1. And 20 is 4 times 5, and I pulled out my I, my square root of -1. Well, now that we've got this will make it a little bit easier for us. I know that this is I and this is I. So now we can start combining some things here. I've got 2i square root of 2 times 2i square root of 5. Now let's talk about that just for a second. 4, square root of 4 is 2. This is my I, and then I'm left with square root of 2. Over here I've got the square root of 4, which is 2, and this is my I. Then I'm left with just the square root of 5. Well, now that I've got that, I can multiply these two. This is going to be 2 times 2 would give me 4. I times I is I squared. And then we have square root of 2 times square root of 5, which would be square root of 10. So I've got 4i squared square root of 10. But we know what I squared is. Remember, I squared is -1. So now I take this and I go, okay, I've got 4 times -1 times the square root of 10. So 4 times this, -1 gives me -4 square root of 10. So again, I would counsel you just to pull out this I first. That will make it very easy. Then you can do the rest of it. The rest of it, if I just gave you the square root of 8 times the square root of 20, you've been doing those ever since Algebra 1. You should be pretty proficient at those at this point. All right, so let's have you try some. I want you to try these two. Push pause on the video now. Then obtain your answer. Come back and push play whenever you've obtained your answers. Check your answers here. So hopefully you're getting that on both. On both of these two, we ended up with an I squared. When you end up with an I squared, that equals -1, and then you'll simplify it further. If you don't, if only one of these had an I, if this were something like -49, square root of -49 times square root of 32, then you'd end up with a 28I square root of 2. Okay, so we're only getting rid of the I because it's I squared. All right, so let's talk about the cycles of I. What happens with I? Well, we've already identified that I to the first power, or just I, is I. I squared is -1. Okay, and that's a principle we've known since the start of this video, but that's a very important one. This one, we could say I is equal to the square root of -1, but we want to keep it all in terms of I here. So I squared is I. Well, I cubed, let's talk about that for a second. I cubed is the same thing as I squared times I. Well, I squared is -1. -1 times I is -I. And then if we go to I to the fourth power, well, I to the fourth power is the same thing as I squared times I squared. Remember, with our exponents, when we multiply the two together, we will add the exponents. Okay, so I squared times I squared. Okay, so we've got -1 times -1. Well, -1 times -1 is a positive 1. Okay, so these are the 4 cycles here. Now let's go on to I to the 5th power. Well, I to the 5th power is I to the 4th, which is 1, times I, which would give us I. I to the 6th power, well, I to the 6th power is I to the 4th, and you'll always kind of go back to this I to the 4th. That will make your life a lot easier. I to the 4th times I squared. Because I to the 4th is 1, so that's why we always go back to it. It's very easy to reference because it's just a 1. So I to the 4th times I squared. So 1 times -1 would give us -1. I to the 7th then, we can keep going down the line here. I to the 7th is I to the 4th times I cubed. I to the 4th is 1, I cubed is -I, so that gives me -I. Well, I to the 8th is just going to be I to the 4th times I to the 4th. And I to the 4th is 1, so 1 times 1 would give us 1. What you'll see is a reoccurring pattern. The easiest way to do this is if we take whatever this exponent is, divide it by 4. We take this 6, divide it by 4, I end up with 1 remainder 2. Whatever your remainder is, we take it over here. 2 is -1. If we do I to the 8th, 8 divided by 4 is 2. There is no remainder. So if there is no remainder, then it's just 1. You'll need a lot of practice on this. It's not an overly complicated one. It's just brand new. So after you get some practice with it, you'll be fine. If we took this one, 5 divided by 4, that gives me 1, remainder 1. And I to the first power is I. So let's pretend that we have an I to the 11th power. I to the 11th power is the same thing. So we go I to the 11th. Let's see. 11 divided by 4 is 2, remainder 3. Well, a remainder of 3, that gives me -I. So I to the 11th power is -I. Okay, I'm going to have you try some right now. I want you to try these 3. I want you to, basically we're going to take this exponent, we're going to take this exponent right here, and then you're going to divide by 4, determine what our remainder is, then we'll go back to what we previously saw in the previous slide. So try these 3 here, and then push pause now. After you've obtained your answer, come back and push play. Check your answers here. So this one if you divide it by 4, it goes in evenly. There's no remainder. That means our answer is 1. On this one here, 29 divided by 4, that would be 28. So that's 7, remainder 1. Well, 1 is just plain old I. Over here we've got 338. We divide that by 4. We end up with a remainder of 2. A remainder of 2, I squared, is -1. Okay, now we're going to move on. A complex number has two different parts. Okay, it's got this a plus bi. It's got a real part and an imaginary part. So let's kind of go through that just a little bit further. Well, I'm not going to spend too much time on that. That isn't as important here. This is what I want to spend a little bit of time on. Complex number has two distinct parts. First is the real part. This is the real number. And the second part, bi. This is what we call an imaginary part. So this is a real number. This is an imaginary number. Okay, so if we had 3 plus 2i. Okay, there's our I. That's our imaginary part. This 3 is just a real number. We've been dealing with those pretty much all of our lives. Imaginary part, that's the part that's new now. Okay, so let's look at this one here. This is the real part. This is the imaginary part. So together, these two are what we call a complex number. Okay, vocabulary, we're not going to have that on the test, but we will refer to these as complex numbers. Okay, so we want to add these two complex numbers together. This is a real and an imaginary. That makes this a complex. This is real. This is an imaginary. That makes this a complex. So we're going to add these two complex numbers together. Okay, well, when we do this, it's very, very similar to the process that we do when using variables. So first thing I'm going to do is get rid of these parentheses. This is an addition sign. It doesn't really change anything, so I can just lose my parentheses. Now that I've got that, I look here and I say, okay, my 8 and my 2 can be combined. Also, I have an I here and an I here. I can combine those two. So 8 plus 2 is 10. Negative 3i plus 5i, well, negative 3 plus 5 is 2. So negative 3i plus 5i gives me 2i. So I end up with a 10 plus 2i. This is my answer. Now the imaginary part always comes second. This is the part that's a little bit different from what you've done in the past. If it were 2x and a 10, we'd go 2x plus 10. But the imaginary part comes second, comes after the number, after the constant. Okay, I want you to try these two different problems. I want you to push pause on the video now, work through your solutions. After you've obtained your answer, come back and push play. Check your answers here. All right. So hopefully you're getting a little bit better at this. We've got a 6i minus 3i just gives me 3i. Hopefully you're writing them in the correct order as well. The number needs to come first, then the imaginary part. The part with the I on it comes second. All right, so we've got these two I'd like you to try as well. Push pause now. After you've obtained your answer, come back and push play. Check your answers here. Hopefully you're getting a little bit better at these, starting to identify them. Now I want to get into multiplying complex numbers. When we're going to multiply two complex numbers, we're going to do a similar process to what you've done for polynomials. Okay, so we've got this one here. If this were just an x here and an x here, we would FOIL these two. So we're going to use the same process. We're going to FOIL these. And in order to FOIL it, we take our first terms and multiply those two together. So here's our first terms. Negative 8 times 1 would give me a negative 8. Okay, these are the first terms here. Now we're going to use our outside terms. Negative 8, let's see, outside terms are negative 8 times 8i gives me negative 64i. Similar process to what we're doing with variables. Now we're going to use the inner terms. 6i times 1 just gives me 6i. That one's an easy one. And then finally we have our last terms, 6i and 8i, that gives us 48i squared. Okay, so I look immediately here and I say, okay, I've got some imaginary parts here that I can combine. I'm going to combine those two. Negative 64i plus 6i ends up with a negative 58i. Well, I also look over here and I go, well, there's nothing else I can combine, but I do know what I squared is. I squared is negative 1. So now I'm going to have to simplify that one a little bit further. So the only thing I did here, I squared, was negative 1. I'm just replacing that. Now I know 48 times negative 1 is negative 48. Well, if you look here, now I've got two more that I can combine. A negative 8 and a negative 48. If I combine those two together, I end up with negative 56 minus 58i. Okay, so this one's a little bit more lengthy than a traditional like foiling problem, but the big thing is do it just like you do foiling and understand that I squared is negative 1. Then you can simplify that one after you end up foiling that one. Okay, I want you to try these two, and this one's going to be important. I'm going to not tell you how to do this one, but I want you to pay specific attention to this one. Okay, it's a very specific way to do it. I'll give you a hint. It's not 16 plus 36i squared. If you end up with that one, then you're wrong right there. So go back in and see if there's another route you can do it. But I want you to try both of these two. After you've obtained your answer, come back and push play. Check your answers here. Okay, hopefully you identified that this one was 4 plus 6i times 4 plus 6i, which does not give you just 16 plus 36i squared. We end up with this 24i and 24i that we have to combine. And hopefully you're getting in the habit, at this point you should be writing the number, the real number first, then the imaginary component afterward. And hopefully you're starting to get the hang of that just a little bit here. On both of these, matter of fact, I skipped one step here just because I didn't have room. I remember I squared is -1. That's where our -20 came from. And down here, I squared here is -1. That's where our -36 came from. All right, now we can use these complex numbers. You use them a lot whenever you're dealing with electrical currents. Here's our big thing, Ohm's law. The voltage on this one is equal to the resistance times the current. So I and R. So if we have this one here, and we've got the current, which is this, which is our I value here, and this one is the resistance. We want to determine the voltage, so we're going to multiply these two together. I want you to do that now. Push pause on the video now. Multiply those two together. That will give us our voltage. Then come back and push play. Check your answer here. Hopefully you found out that the voltage was 6.15 minus, and just because it's in decimal, that doesn't mean that our order changes. Our order is still, the imaginary part comes after the real part. I have a similar one to the one that we just did here, with a little bit different current and a little bit different resistance. I'd like you to try this one. After you've obtained your answer, come back and push play. Check your answer here. All right, I want you to try these two. Push pause on the video now. After you've obtained your answers, come back and push play. Check your answers here. This one you should have gotten at this point. This was similar to a real previous problem that we did. You can go back through and watch this video. This will conclude our video. I do have some other problems on the homework that you can work through, that you can view the video on, as well as on the YouTube channel if you want to go there. But you can go back through and watch it a couple times if you need a little more assistance with it.